So for this question, right, will illustrate how we're going to add the area under graph. But for this question, it involves a bit of differentiation idea. How do we know that it involves differentiation? Because it mentions something about normal. So it mentions something about normal. So normal is related to tangent. And if you still remember, tangent is explained through a dy dx. Dy dx is the gradient of tangent. So during differentiation, we got this idea, but it's easily forgotten. Okay, so you got to be using this idea to prove part A, to prove A equal to 1. A equal to 3. So the relationship between normal and tangent is being perpendicular. So I hope you still remember that one comes from under application of differentiation. So that's why I calculated this gradient. I calculated this gradient by using Courtshott. So I calculate the normal gradient, OA. I also calculated this gradient by putting in x equal to 1. So by putting in x equal to 1. Okay, so how do I know the tangent is going to be -1? Do you remember? Because they are perpendicular, right? This gradient multiplied by this gradient will be equal to -1. So this times this will be equal to -1. So now I know that this one will be confirmed a -1. So it will be a -1 when I put in x equal to 1. So I put in x equal to 1, and that's how I get A equal to 3. So A equal to 3 is obtained mainly from your concept of tangent and normal. Tangent and normal being perpendicular. And so if you cannot prove, if let's say you fail to prove, well, you take it along. You take the A equal to 3 and continue. You will still be able to score for the rest. So if you didn't get it, so the A equal to 3, put it in here. So even if you can't get it, you put it in, and you can find the equation of the curve. So to get the equation of the curve, of course, you got to integrate. So to get the equation of the curve, you got to integrate your dy dx. So I integrate my dy dx, and there is a plus c. The c is meant for you to find it. So this one is in the previous part of integration. So you need to use a given coordinate. So if you got any coordinate, then you just use it. So here I got, this is on the curve. That's why I sub in A. I sub in A, I managed to get C equal to 0. Okay, so if you forgot about your C, you assume that it's 0, right? Even though the answer is correct, you will get penalized by not doing the correct steps to show that your C is a 0. Okay, so you need the equation of the curve. You need the equation of the curve because subsequently, if you do not have the equation of the curve, you cannot perform the area under graph. Okay, so you will need the equation of the curve, which I've gotten here already. Then I can perform area under graph later on. Okay, but before I can even do the area under graph, I got a point B to find. Okay, when they say point B is tangent to the x-axis. tangent to the x-axis. That means, right, dy dx is actually equal to 0. That means the gradient is horizontal 0. So they are saying that the tangent is horizontal. So tangent horizontal means it's gradient 0. That's why dy dx is equal to 0. So some people will get stuck at finding b. So in order to find b, your dy dx is equal to 0 because it's tangent to the x-axis, and x-axis has no gradient. So from here, you find two possible answers. So when you get two possible answers, you got to think it should be equal to 2 because it comes after 1. So there is no reason why you should choose coordinate of b to be 2/3. Okay, so you found your coordinate of b. Then eventually you are finding the equation of the shaded area. So what I normally do is I will color, and I realize that this part is under the curve. So part of the shaded area is under the curve. And then this is another equation. Then part of the shaded area is under the blue one. So the shaded area, it has two separate sections. One is under the blue equation, one is under the red equation. So I'll be adding them up separately. So under the blue one is a triangle. So if it's an obvious triangle, and it's quite easy to tell that it's 1 times 1. Base times height. Half times base times height is half times 1 times 1. It's actually quite easy to tell. It is the one that is under the curve. The one that is under the curve, where are the two vertical walls? Is 1 and 2. So the one that is under the vertical wall is 2, 1, and this is the curve. So you need to integrate your curve. So integrate first, then you do the top minus bottom. So you got the blue area, which is the triangle. You got the red area that is under the graph. So these are the two areas that make up the shaded area. So you just add them up. So that's how you approach an area on the graph.